Good morning. My name is Bethany Maddox, and I'm a member of the customer care team here at Vitech Corporation. I'm very pleased to be your host for this webinar today as we welcome Warren Smith and Jim Obermeyer presenting What's New in Core 9. Before we get started, I'd like to take a moment to review a few technical details. First, questions. Please feel free to submit your questions at any time using the questions and chat function in the GoToWebinar window. We will be monitoring these throughout today's event, and we will have a Q&A session at the end of the webinar, so stay tuned. Near the end of the presentation, I'll be picking 5 attendees to win a copy of our primer for model-based systems engineering, so stay tuned at the end of the Q&A session when I'll make that announcement. Finally, the webinar is being recorded today. An online archive with this presentation will be available within 24 hours of the live version. I believe that takes care of the housekeeping, so let's get started. Let me introduce our 2 presenters today. Jim Obermeyer is Vitech's Vice President of Business Development. Jim came to Vitech from a private consulting company, Sales Leakage Consulting, and is also a co-founder of the Sales Lead Management Association, currently serving over 6,300 members. Also presenting today is Warren Smith, an accomplished systems engineer and one of our senior account executives. Warren has 25 years of experience in systems engineering, working as a program manager, field engineer, and entrepreneur. And now the moment we've all been waiting for. Welcome, Jim Obermeyer, Warren Smith, and Core 9.
Thank you, Bethany. This is a great day at Vitech Corporation to introduce Core 9. This is a wonderful product. It has great features and great benefits for the systems engineering community. And we are really looking forward to it. In fact, I'm looking here, what's coming across my screen. I can look at all the chat. We're getting questions coming in already from those in attendance, and the attendance is going up, ticking up, one person after another. This is a wonderful morning. Warren, I'm really looking forward to this today because this new version of Core has some long sought after ask features from our user database, and I think they're all going to be suitably impressed and really enthusiastic about what this new Core 9 will do for them in so many areas. So Warren Smith, our systems engineer and account executive, take the program away.
Thanks, Jim.
Isn't this great?
It is great. It's a great version of Core. There's a lot of awesome capability in it, and I'm really excited to be with you and Bethany here today to talk about it and share it with our customers and the people online. Core 9 actually has capabilities in 4 different areas. You can see them here on the screen. There's new modeling capabilities. We've added parametric capabilities to manage parameters. We have a new state transition update to the diagram. That's a fantastic capability. I'll be showing that. And we've refreshed the sequence diagram and changed the look and feel. There's new model diagnostics. One of the benefits that model-based systems engineering provides, or should always provide, is the ability to show you defects or consistencies or inconsistencies in your model so that you can see them and fix them and change them early on in the design. And Core 9 really accelerates and advances that capability. There's new simulation capabilities inside of Core 9. We have new collaboration capabilities. There's a new DOORS connector, the ability to interface your information more easily and seamlessly with DOORS. We've always had an interface with that, but this really cleans it up and makes it very easy to use. You can see a whole slew of capabilities regarding notifications and email interface and cross-project relationships. It's a great version of Core, Jim. I know that our users are just going to really appreciate it a lot.
Okay, let's get started then and see. You're going to start with the cross-project relationships. Now, tell us, why is this so important to the end user?
Well, I'll tell you what. Particularly our larger customers, this is a capability that that they'll really appreciate having. The cross-project relationships, obviously, in a demonstration like this, I'll be able to demonstrate a lot of these capabilities, but the cross-project relationships is kind of hard to demonstrate. So I wanted to talk about it with this slide. The reason it's important is that there's a lot of companies that have different system variants. They want to reuse those. They want to model family of systems or systems of systems. They want to do advanced baselining of their project data. And the cross-project relationships allows them to do that, to have information in, say, a variant, but link that back to requirements or designs or tests from a common database that might be used across all family variants and the family of systems, the variant lines. Product lines is where I was looking for. So you can traverse those behaviors across the different projects. It supports the diagrams and document generation and simulation. It's going to be a boon to our customers that that really have that type of product line structure. We're also going to, I'm going to show the connector with doors today. We actually have 3 or 4 different scenarios that we support. We support, obviously, core does requirements generation on its own, but oftentimes we have customers where they use doors as an authoritative requirements repository, or they have to take system level requirements from doors and bring them into core as the starting point for their detailed design, and then they would generate lower level subsystem or component level requirements out of core and round trip them back to doors. It's a very full featured capability that handles all of those scenarios. We're only going to show one today in the interest of time. We're going to show doors as an initial requirement source. So I wanted to put the slide up, Jim, to let people see that we do have a full breadth of capabilities now with this very powerful doors connector.
Now, we could always do this in the past. We just did it a little bit more manually, didn't we?
Yeah, actually, that's a very important point. Yeah, there always has been the ability to get information into core from doors and send that information back out. But you're right, it was more manual. You'll see that this and the CSV parser have been promoted in the to the menu structure, and there's a nice simple wizard now to get that information in and out of doors. It's really slick. The notification center, this is something else that's kind of tough to demonstrate with just one person, so I wanted to put the slide up. The notification center is a new capability, and you can see that it's just a button straight on the core menu, and what it does is it notifies you as a user when other people are changing elements of the model. As our current customers know, core does not use kind of that cumbersome check-in, check-out approach. We have access to live data. Every user has access to live data in the repository concurrently. When changes are made, our transaction processor makes sure that they happen in sequence with history, but everyone's always looking at one version of the truth that represents the system as it stands right at that moment. But nonetheless, people often want to see what changes are being made by others. The notification center gives you the ability to view those kinds of changes. It doesn't show you your own changes, which makes sense. But obviously, since I'm a single user working on this demo today, it won't show me my changes. So I wanted to put this slide up. The benefit is that. Go ahead.
As a user, I've got a choice, don't I, of whose changes I want to see.
It's completely configurable, and you can identify them accordingly. You can clear them out and so forth. It's an awesome capability. We have some new capabilities regarding attribute locks and element locks. For instance, this diagram here, this screenshot shows the project unique identifier. Core has always had an unchanging project unique identifier, and it's a standard capability when identifying elements inside of any system, whether it's requirements or designs or functions and so forth. But we have some new capabilities, like this one shows the lock when set. So when it is initially set, that PUID now will never be can never be changed by another user when this setting is initialized. So there's a number of capabilities regarding freezing the design, and we won't be talking about these today, but I did want to highlight them for people before we got into the demo.
What's the real benefit for the end user on the freezing the design? How often will that be used? And
yeah, it's going to be used fairly often, and the benefit is that it's one of those capabilities where if you need it, if you need to lock down your data in those types of ways, no other feature will do. So it's going to provide support to those users that really have rigorous need to control data. Sometimes it's space applications, sometimes it's in medical device. It depends upon the user, but those users that need it will be very happy it's there.
Okay, thanks.
Yeah, so we have a few other things in here. I probably won't be able to get to these today. Some of them you can't really see, but like the server-based export, we've had some under-the-hood capability improvements that are just phenomenal. The export has increased by 100%. The test database that we used went from a 40-hour export to a 24-minute export. And clearly the benefit of that is evident to anyone that needs to do that type of work. We have some new capabilities regarding the diagrams, project registry. The model assistant has been updated to include new capabilities in our state transition models. The simulator has more integrated simulation between performance and operations for our DODAF users and so forth, and we have much more access now to the various objects of simulation, the triggers, and as well as the functions and behaviors and so forth. It's very exciting. I don't think that we'll be showing the simulation today, but you know, I wanted to mention it here just in the interest of time. You can see that we have additional reporting. I'll be talking about some of that. Fantastic. And then we have new capabilities with email integration. So that kind of gives us an overview of what's new, plus some of the things that we won't be able to get to in the demo. Do you think we should shall we get started with the demo, Jim?
Yeah, let's get started. But for everyone out there in the audience, just remember you can use your chat button to request from Bethany. If you see something and you say, yeah, I'd like a personal tour of that, just tell Bethany and she'll take down your name and we'll make sure that you get a personal tour of anything that we're showing here today. From your account executive, from Bethany, we'll make sure that you get that personal attention to look into depth on those items that you're really interested in. Go ahead, let's get started with our Core 9 demonstration. Yeah, now you're building this right from scratch, aren't you?
Yes. In fact, we'll let me touch on that second bullet. We're actually, you're right, we're building this from scratch. You're going to see I'm going to start with an empty repository, and then using the concepts of a reusable design library, we're going to populate over the course of about 30 minutes a complete system design, full up with requirements, architecture, behavior, the whole 9 yards. And the reason that I want to show this is that you know, too often companies develop capability and they pay big money to do this, but then that capability is locked up in people's heads, or it's in documents that may not be complete. A system level reuse library is really one of the most profound ways that engineering organizations can increase their productivity and turn that kind of tribal knowledge into corporate knowledge. It's an amazing return on investment that that model-based systems engineering provides over and above everything else that's ever come in the past. And so I wanted to demonstrate how that works today. We're going to do it on a medical device. It's a breathing device. I call it the quote-unquote Vitek ventilator. It's a respiration device to help people breathe when they're sick in the hospital and so forth. So let me go ahead and switch over.
So we're starting with a clean sheet here, right?
We are. Okay. So so can everyone see? Can you see Core 9 up here?
Yep. Ready to go.
Okay. So so this is the home page. I'm going to go ahead and go to this project here. The way Core is laid out, and some of our existing customers, this will be redundant, but if you can bear with me, we actually have a series of classes, buckets, if you will, that hold different capabilities in an Explorer view. And you can see that these are primarily empty with this project. One of these, I've got components here. I can actually highlight a top-level component. Here we have the top-level element for the Vitek ventilator system that we're going to be building today, and you get a list of components here. You'll see these lists fill up. Also, we'll have behaviors in the functional area or in the state area. We have requirements. We'll have tests and so forth. Over here, this property sheet here is what we call it. It identifies all of the different attributes that this one element can have. And it's completely customizable. You can modify the elements. You can modify the values that you could select. And then relationships are captured down here. This actually isn't used so much anymore because we have drag and drop relationship capability that you'll be seeing throughout the demo. Any element can be viewed in a number of different ways. Here is a simple hierarchy diagram. A hierarchy of one element isn't very exciting, but there you go. So let's go ahead and kind of get started here. I'm going to switch over to kind of shortcut view in my essentials list here. It's a subset of those other classes that we're showing. So I'm going to go ahead and start importing some information from our reusable design library. So I'll go ahead and go to the Vitek Ventilator Library here. And what you're going to see are different subsystems that can be sort of plugged and played, plugged together inside a system design, complete with requirements and design and tests and the whole 9 yards. There's a couple key subsystems to this ventilator, this breathing system. The first is the respiration unit, and you can see that we have 3 different styles. One for a child, one for an adult, and one for a more elderly person, because every a person's breathing capability varies as they go through life. These are all designs that have been developed by this company, this fictional company, and they reuse these with slight variations over and over again. We also have the control system. There's two or three variations of this as well. We have the hospital type control system that controls the actual respirator breathing component. We also have a portable type for ambulances and EMT. And then it looks like this system has actually maybe used the portable one as an Army unit, probably ruggedized it for use out in the field. We're going to design a ventilator system for a child for use in a hospital. So I'm going to go ahead and import this into our empty design. So I'll go ahead and import this data live.
So you could just as easily be importing an engine, you could be importing a component on a vehicle, a satellite.
Exactly. Every company that does what they do has variations of their own products. Using the power of model-based systems engineering in Core 9, you can easily manage the reuse and the baseline of the common components. And And so that's really what we're doing here. So you can see that after that import, we now are starting to get some things filled up. We actually have a nice little component structure here. We have some requirements, a few of them, some risks. Let's go ahead and look at this top level. You can see that this is the respiration unit. If I look at the hierarchy of this kind of gives you a little picture of what this looks like. It's someone in a hospital bed with a breathing apparatus, a tube, the pump itself, and some sort of control system. It's a notional diagram. This is actually the top of the product hierarchy. You can see that there's the patient interface, the tubes and so forth. There's a battery backup, which we'll talk about more. And then there's the respirator unit itself. This is separate from the control system. The control system we'll look at a little bit. With Core, of course, you have the basic capabilities where you can look at the product hierarchy and stretch these things out. You can also look at it from a different perspective, like a flow perspective and so forth. So here you can see the exact same subsystems, the battery backup, the patient interface, the respirator, and you can see that we have some interfaces here that are external interfaces that later on we'll see about connecting this piece, this subsystem, up with other subsystems to make the total system model. Now, one of the things that you might notice, I'll just pause here for a moment, you'll notice that the colors are a little bit different. I find them more pleasing to the eye. The buttons and controls have been laid out for more ease of use. Things like I don't think I'll be showing you today, but this is grayed out here, but that's the simulator button. It's right there. You don't have to go searching around for the simulator. So the look and feel is really nice with Core 9. Now I'm going to go ahead and talk, since we're talking about the respirator, I'm going to talk a little bit about risks. Clearly, with any medical device like this one, where you have life-saving capability, risks are going to be an important element to track. We've always had a risk capability, but with Core 9, we've enhanced it. You can see here we have a couple of different risks. The power outage is a key one. We're planning on deploying this ventilator to areas that maybe to countries and so forth that have frequent brownouts or power supplies that aren't necessarily reliant. So that's a risk. You don't want the power to go out on a respirator that's keeping a child alive. But what we've done is we've gone ahead and identified whether it's open or closed and whether we've mitigated it. We've made a design decision to put the battery backup system in the breathing apparatus so that even if power does go out, the breathing can continue to the patient at whatever the preset levels were. And we also have some other information that we're tracking here as well. The likelihood of occurrence down here, in some of the areas where this device would be deployed, is highly likely. And what are the consequences should that risk occur? Well, obviously, it would be severe. So we've gone through, pardon me, and identified risks for 3 different areas. The risk of passing airborne diseases, the control system failing, and so forth. We've identified the number of man-hours necessary to add to the design to mitigate the risk with each of these as well. So what's new in this? Well, one of the things that Core 9 has done is we found that a lot of our customers are doing risk mitigation design approaches. So they're capturing their risks. They want to trace those to the design, and they want to report out on them. So Core 9 actually has an explicit risk register that allows us to output these risks in some very nice formats. We have the risk cube, the risk table, and we can also show details. Those are selectable, and we'll go ahead and select them all. I'll put these into a report area here. This generates a Word document directly, so it has taken us out of Core and into Word with an RTF format, you will notice that that it's got a heading page. You'll see on all of our reports. You've got headers. You can put your own logos on them, tables of contents when it's appropriate, and so forth. And what Core has done, as the risk output has shown, is taken all those risks. It's taken the severity and the likelihood, and it's mapped them into the cube. And you can see that the power outage is actually the highest level risk, although the control system failure, which has similar behavior, is right up there as well. If we look down, we can see a table, if people like that better, and look at it that way. It's important to note that with Core, each one of these reports, like this report, can be auto-generated every night at midnight and be waiting in an email on the program manager's desk when they get in the morning, if you'd like to do that. The details of each risk are captured here. It identifies the severity, the description, the mitigation plan. I mentioned the number of hours it will take to mitigate that cost. That can be put in there, and so forth. So each of the three risks are all captured in here. So so really the value of this is that companies using Core for their model-based systems engineering approaches can identify their risks early. They can design in solutions, and these risks can all be linked directly to program elements that mitigate those risks. So,
how was all this tracked before, though? With you know, as you as a systems engineer working on other projects, how did you used to track this sort of thing?
Well, I'll tell you what, a lot of the people I talk to who haven't deployed Core yet are doing it using PowerPoints. They often have to report them out at programmatic reviews or milestones, and they don't track it constantly like this does. Instead, they do it on a point-by-point basis, and they have to update it by hand. It's a lot of work, and it doesn't provide this kind of concise, unique, real-time reporting. So.
Okay.
Yeah. So that's really a really cool new capability. So let's talk a little bit. Let me go to the requirements here. There's a few requirements here relating to this respiration unit. Remember, this is kind of a bottoms-up design. We'll be getting a lot of requirements from the top-level requirements document that we'll be importing later for that purpose. But let's take a look at one of these requirements here. This is how often the respirator will breathe for the child. So it's called breaths per minute, and there's actually a capability, a capacity to deliver a certain number of breaths per minute. Now, when you look at this, you might think, "God, that's kind of an odd looking duck there. What's going on there?" Well, what we've added into Core 9 is the ability to manage parameters and to actually tie those parameters directly into textual outputs. So requirements or tests or anything else that you might put out to a document or hand over to someone else for detailed design, you don't have to manage all the updates to those texts. You can actually do it here using the parameters. So the parametric tab actually allows me to add user-defined parameters. So here I've identified the minimum and the maximum number of breaths per minute for this particular device. And I'll go ahead and change this from 4 to 2. You can see what I'm talking about. You can see that the reference has been updated. If I want to add other parameters in here, there's actually a pre-canned list that comes with Core 9 now of all the different parameters that are possible for each data type. So these are parameters that are available for requirements like repair time or interoperability. There's a different set for components and for functions and so forth. So what does this mean when we output this? I don't have to manage the text. I can just manage the parameter, and then if I output this, I'll go ahead and generate a system description document very quickly here. Let's see. same kind of deal. It'll generate a Word document, and it's complete for this subsystem with the data that's in the tool. And if I want to, I can have Word update the table of contents. But what I'll do here is I'll do a quick find. We're going to look at these a little bit more, but I just want to show you that I changed the parameter, but I didn't need to update the text. The text of the requirement changed from 4 to 2 automatically. That was a capability that Core managed for me. Isn't that cool?
It's very slick. That's and it gets reflected
I like
in the
it.
report. Yeah, it's very nice. Allows the engineer to do engineering work and not worry about these kind of scope details that are hard to track.
Exactly, and it lets them manage those parameters centrally, so it saves them time and it saves them money. So while we're on the requirements, let me go ahead and show another new capability. There's the Diagnostics tab down here next to the parameter tab.
Warren, it's yours. Take it away.
Thanks a lot, Bethany. Yeah, well, I'll tell you what, it's still cheaper than traveling to Blacksburg for the rollout, right? But I also appreciate everyone that hung in there and during whatever kind of crash that was with our webinar software. So let me pick up where I left off. I was about to talk about this new diagnostic capability. Core has always had the ability to identify inconsistencies and incompleteness within the model. What's the point of having a model-based systems engineering approach if it can't answer rudimentary questions for you? And we've always felt that way, but what we've done with Core 9 is brought that up to the fore. So with the Diagnostic tab, Core 9 is always assessing the consistency and the completeness of every element. If you look at this requirement, for instance, remember this was the breaths per minute requirement that we talked about a moment ago, several moments ago. You can see that there's a level 3 completeness error. The element is a leaf level requirement. It's got some conditions, but it's not verified by anything. In other words, this is an untested requirement. How often do you get through the specification, the analysis, the design phase, start integration and test, only to find that mismatches in your design that could have been identified early on and fixed for mere pennies now take thousands of dollars of time and materials to correct. This is the type of real value cost savings that the model provides. Let's go ahead and fix this. This requirement here needs to have a test that would be something that would verify the requirement. So I'll go ahead and double click on that and create a new verification method. So I'll just say that this is to test the breaths per minute, and that's it. It's now linked up. I can actually literally edit this and put my test procedure here, whatever it might be, and you can see that goes into the verification area. And when I go back to my diagnostic report, I see that completeness error is fixed. The other one is that the attribute, the requirement type isn't set. Well, this is a performance requirement, and so I can set it accordingly. You can see that with just a couple clicks of the mouse, the model told me, Core 9 told me where my errors were, and I was able to correct them very, very quickly. Obviously, writing the test procedure would take some time, but it reminds me that I need to do it. And these consistency checks actually show up throughout the entire system. Let's see. Let me get my bearings again. So let's go ahead and import the next piece of our model. As you recall, we've imported the respirator, and now we're going to import the control system. Now, I pointed out that there were 3 different types of control systems. We're actually doing the hospital variant, so that's probably going to be bigger. It's not going to be as rugged. It won't work on, say, 12 volts that you would have in an ambulance and that kind of thing. But again, from our reuse library of previous design components, we can bring this in. And you can see that it's starting to flesh out more. We have a state model now. We have some more component information here. This is the ventilator control system that controls the respirator and the user interface and that kind of thing. Let's go ahead and hook these things up now. I'm going to go ahead and move over to the top level, the ventilator system itself, and I'm going to add into it the ventilator control system. I can do that through a drag and drop. Our Core 8 users are familiar with this capability. I build it in. I can also add the respiration unit in as well. And now we have our system and the 2 pieces are hooked up. Now, of course, making the hierarchy is important, but we actually have to connect up the actual interfaces between the respirator and the control system. So let's go ahead and take a look at those. The respirator, I think I mentioned earlier, if people recall, had some external interfaces. Here's some sensor data that comes across from the respirator, and that sensor data has to go from the respirator to the control system. It measures the air pressure and so forth, the oxygen content. And then there's some control data that comes in from the other system to the control system to the respirator. And so that's regulating air humidity and so forth. Let's take a look at these interfaces real quick. And I can open it up. And again, I can check the diagnostics, and I can see that they're unconnected. The connects to relationship doesn't have 2 targets. One end of the element is unconnected. So let's go ahead and fix that. I'm going to go ahead and do that by attaching the ventilator control system to the other end of this this link. Makes that. Do the same thing over here. Makes that. I can adjust the labels a little bit if I want to, make them a little bit more readable. And when I actually go back then to this property sheet, we can see that one of those 2 completeness checks has been corrected. And one last comment on the completeness checks. This is actually one of the most important elements, I believe, of model-based systems engineering. And if you have a tool that doesn't do this, I don't believe you're doing model-based systems engineering. You know, manually checking consistency is something that systems engineers have been doing for 50 years. So the last piece of this is that I'm going to I think I've hooked everything up. I have. Let me move over then to another new capability within Core 9. I'll go ahead and look at this ventilator control system. The respiration system that we looked at, it had a lot of hardware and electronic design, RS-232 interfaces and so forth. But this control system is really going to be more software oriented. So let's go ahead and open up the state transition diagram for the control system portion of our ventilator. So here's the state model for it. We've greatly enhanced the state transition diagrams inside of Core 9, and it's really nice. It has all the standard capabilities that you would expect. This little dot here means that this is hierarchical. I can go into the substates associated with that, and I can actually build out this model. I'll go ahead and do that now. What this model shows is that Remember I mentioned that the respirator itself will have a battery, so that if there's a power outage or the control system fails, then the patient is still getting air. So when the system boots up, it needs to determine the status of that and to figure out if it's a normal system startup where the respirator is off, or if the respirator is actually working in the emergency mode. So let's go ahead and create a new state. If it is in the emergency mode, we'll need to synchronize the control systems of this. So we'll add that in, drop that down there. We can create a new transition between these two, so I'll go ahead and do that. Create a new transition. It'll populate that for me and put it on the diagram. I can create a new event for triggering this transition, and that is will trigger out of the previous state when the status has been collected. So we can put that on there. Stretch that out a little bit. I think the last thing too that we want to do is when we're done with this initialization, I want to have an action occur. Very specifically, I'm going to have it beep. So I'll go ahead and drag that on and hook that up, and there we go. Very easy. I can add my termination as well. I can put a new exit transition on there, and yeah, I can move that around if I want. But basically, I've got my new state model. So the ability to create these is very easy. We have lots of capabilities for capturing call types and guards and that kind of thing. All the standard stuff that you would expect is all in there as well. But in the interest of time, since we did lose some time, I'm going to press forward and talk a little bit about what I believe is a very innovative implementation of the state models by Vitek and Core 9. If you look at the ventilator operations, you'll see that we have the entry and exit actions and the do activities. Let's take a look at this patient setup. If we look at any one of these, in fact, I'll just navigate straight over there accordingly. We can look at the behavior associated with this, and we can look at it in a number of different ways. For instance, I can look at it in an activity diagram. I can look at it as a functional flow block diagram. I can look at it as a sequence diagram. Think about that for a second. One of the great, I wouldn't say chasms, but one of the great gaps in modern systems engineering is the difference between the perspective of the systems engineer, who is often using this type of model, and the software engineer who is using a state model. But what do states do? Well, they perform functions, they do behaviors. And if you want to now with Core 9, you can bridge that gap. So it's a real benefit. Obviously, if you update any one of these models with new behavior, you can switch back and forth, and every single diagram will have that information shown. If you allocate, like for instance, if I allocate this to the display, I can do that with a drag and drop, and then watch that thing move from here over to here. So Core is keeping track of all these important details while you actually think about your design. It does the perspiration while you're doing your inspiration. Let's see. I think that mostly covers the state model. Are you online, Jim? Jim is still not with us. Okay, I'm sure that he'll be joining up in a couple of minutes.
Hey, Warren, it's Bethany. Warren, Jim is online, but he is having some mic issues that we're trying to resolve. We may be fixed, but you might want to go on without him.
Okay, well, that's fine. What I'm going to do then is the last piece of this. I think that we'll be running over because of the difficulties, but not by much. I'm going to show you the last piece of this. and that's the import of the system level requirements. Clearly, Core does this work, but many of our customers use DOORS as the authoritative requirements baseline, and that's good. And what we've done is we've made it easy to map to that. You can see that we have a couple of areas here where we can do round tripping. We're going to do a DOORS import of requirements from DOORS. We could also be exporting and round tripping any requirements, including subsystem design requirements, back to DOORS. Let me go ahead and show you how that works. I'm going to run over to the importer again, and instead of importing reusable subsystem design, I'm going to import some requirements from DOORS. Before I do that, let's actually take a look at DOORS and see what we have in there. I'm not going to do a DOORS demo, obviously. People that are familiar with DOORS will recognize this. This is a very standard document structure. DOORS has a unique object ID that uniquely identifies all of the objects in this document. It has a paragraph structure. These section headings, scope, applicable documents, requirements, and so forth, they're called object heading. The requirements and text itself is called object text. And then associated with the paragraph number, there's a hierarchical structure called number. Now, anyone that knows DOORS knows that you can put in user-defined views to look at the data however you want. And with Core, we're going to use a view that we defined that will be available to all of our users that formats the data for export to Core. Okay, so those things I showed you are still here. But they're broken out. The object ID, the paragraph number. You can see the paragraph number here, the heading, the text. We're also capturing some other information, when it was last modified, what type of requirement it is, and we also have a name that we've put together with a little script that is available to our customers that creates a nice core name of this DOORS requirement, and it has the object number in it and the section heading. So let's go ahead and export this data. We're going to go ahead and use the standard DOORS exporter. We'll browse to our library. We'll put it here. Okay, and we'll just go ahead and do the export. It's done. It's taking us back to Core, and I'm going to highlight this requirements, and we'll go ahead and do our DOORS import now. Remember, I said that we can actually do round tripping. I don't have time. I didn't have time before the technical difficulties to show that, but we can show that to anyone that is interested. Now, I've selected the data file that we exported from DOORS, and now the wizard will walk us through the magic that it does. I'm going to select an area to import those. You can see that we have a couple of different options. We're only importing requirements in this example. And we have a couple of different maps that you can use. So I'm going to go ahead and load a map, and it will map each of the elements from DOORS into a corresponding element in Core. So some of these are attributes. You can see that we have some other things here, classes and element IDs and so forth. So having done that mapping, all I have to do is make some selections, tell it that there's a header row and what it should do with certain parameters and relationships and so forth. And then it will do its work. So the value of this really to many of our customers is that we've made it easy for them to keep the requirements in sync with design elements in DOORS and in Core. Core is a tool that's capable of performing all those different types of design analyses, architectures, and so forth, of behavioral analysis to derive subsystem and component requirements. I mean, they don't just spring from people's head fully formed. You have to do analysis, and Core really does that well. It also does terrific requirements requirements analysis and requirements tracking and traceability, but a lot of people use DOORS, and they need to keep those functional and performance interface requirements synced. So this interface here allows us to do that round trip. So even though I'm showing just a simple one-way import, today you can know that that you can actually seamlessly round trip between the two tools and keep everything in sync. So you can see here that it's done its deed, and we've got all these requirements now in the requirements baseline. Think about this. I've been demoing for just over 30 minutes. I started with a clean slate, and now we've got a very complete, and for 30 minutes, system design using the power of Core's reuse library capabilities and importing requirements as well. If I look at, this is the top level requirement. I'll call this the SysRQT1. It's the heading. You can see the paragraph title has been populated there. One of the really neat things about the import is that it actually built the hierarchy of these requirements inside of Core. It was seamless. It was just part of what it did. I'll go ahead and open it up in a bigger view for you. And you can see here all the different requirements sections. You can see the subsets. If there are children, you can see what those are. You can open any of them up and see what the text is. And you can browse them very easily in a nice graphical view that, that really adds value from the core view of those requirements. If I want to renumber them, I can do that here, and you'll see all of these will get populated with numbers. Same in the other view. And then the last thing I'm going to show you here is how these requirements can actually be allocated very easily inside of Core to the various subsystems. So you can see that we have some control system requirements here. I'm going to go ahead and bring up the control system component. There it is. How do I allocate these control system requirements to this piece of the system? I just drag and drop. So I'm going to do that, and I'm going to do this on a number of these, so we can have those allocations and generate some outputs. We have some alarm requirements. Obviously, in real life, I would be assessing these a little bit more, but you get the idea. And go ahead and do that, and so on and so forth. So I won't. I'll do one more. I'll do this one here. Respiration. Okay, so we're almost done with this. We've got a very complete model. We've got nice structure. We've got behavior, both functional behavior and state behavior, and they're linked together. We have component hierarchies, and the whole 9 yards. So let's go ahead. I'm clicking too fast. Let's go ahead here and generate some output. Document generation obviously is an important part of any system design. I'm going to go ahead and create the system definition diagram. I could do it on any of these components. I think I'll choose this one. Imagine for a second that we wanted to subcontract part of our design out to another organization. Well, how would we do that and keep all the behaviors that interrelate between their portion of the design, our portion of the design, all the interfaces? How would we keep that all in sync? Well, we don't have to. We put it into Core 9, and then all we have to do is output a document like this one and give it to the supplier or to the group in-house or whomever, and they can use it as a comprehensive, complete specification. With the diagnostics, we know that there are no errors, and if they build this, then it will work. You can see here again, some of these sections will be empty. I could have selected which ones I wanted to incorporate, but let's just take a look at this document and see what our work has wrought here. So here's the ventilator control system. We have some nice descriptions associated with it. It identifies certain functions that are allocated to it. We have some requirements that we imported from DOORS. It shows interfaces, inputs and outputs. It gives us context diagrams directly from the model. It shows external interfaces. The ventilator talks with these two data links, the control and the sensor links, to the respirator. It's shown up in blue since that's another spec, another part of the design. Here are the details of those requirements that we imported from DOORS. They could have been native in Core if that had been the setup, but there they are. It shows the unique identifier from DOORS as well, and all the different information that's associated with that. These could be all parameterized inside of Core. So we can go through those. There's sections that I could always complete. Our risk analyses, we don't have the nice charts in here because that's not really the purpose of this document, but the risks are talked about. What type they are and so forth are all captured inside of this document. We spent a lot more time on that, so I'll keep going. The behavioral analysis, here's the functional behavior. Here's a list of all the elements that have to interface to that. And you can see that we can send this information over to our software developers to build that. It shows the behavior, the functions that these interfaces trigger. We have detailed analyses. We have sequence diagrams that I didn't create this. It was auto-generated by Core and then output into this document. Here's one of my favorite areas, the item dictionary. Data dictionary, as much detail as you want can be output. You can see that here's some of the signal data and how it's transferred. Later on, you're going to see that it was an RS-232. You can see what the range is, what the units are, percent oxygen, and it's all just right there. In fact, I know some people that they use this report. All they do is output the data dictionary and use that as the master for their data in the system development phase. It's pretty cool. Here's the interfaces. You can see direction. You can see the behavior. This is all relative to the patient setup, which I showed you. The direction of the interface, what the interfacing item is, and then who produces and consumes it. So, you can go on through. Here's the here you can see the protocols associated with links. Traceability matrices, higher level over here to detailed requirements. It's pretty amazing. You can see that some of these were traceabilities that were imported from DOORS. Some of these, like this one, were traceabilities that I created between the architecture and the requirements inside of Core. So I'm talking really fast. I think that's pretty much it. I don't know who's on right now, Bethany, but I'm going to. Hey, I'm going to bring this back up.
Yeah, I'm back, I think.
Hey, Jim, good to have you back.
Yeah, I've been sitting in the background. So, Warren, what are you most enthusiastic about as a systems engineer of all? I know you like it all, but what is the thing that impressed you the most about Core 9?
That's a good question. It's going to sound strange, but the number one thing I'm excited about is the diagnostic tab. I've worked on a lot of systems over the last 25 years, and frankly, I've been burned by poorly defined interfaces or missing functionality, and we don't discover it until all the money's been spent and all the time's been used, and we're in integration, we're trying to get the stuff to work, and oh my God, we find that someone omitted a key interface, and we have to go back to the drawing board. The ability of Core 9, the diagnostics, to identify every one of those things in the analysis phase is amazing. I mean, people have seen that cost curve, the cost of fixing a defect, and people say, yes, but it's pennies in analysis and millions of dollars in fielding. Well, how do you find a quote-unquote defect in analysis? I just showed you how. Core 9 does that. That's the #1 thing that I love in this.
Okay. I was just curious your feeling as a systems engineer. So you've gone through the modeling power and the model exploitation, the team collaboration, and the model management. This looks looks great, and we're kind of over time now. But Bethany, do you have some questions? Can we go over to your portion now?
Oh, do we ever have questions? They have been coming in since before we opened the session the first time. So
did we lose any questions, Bethany, during the system
they're
problems?
all captured. I'm not sure that I have them all to ask you today, but every question is captured. And if we don't answer a question live today, rest assured that we will contact you one-on-one after the event to make sure that every question is addressed. Okay, so before we get started, I have a few special guests to introduce. Joining us for the Q&A session is Donna Long. Donna is the Core QA Manager and a Senior Systems Engineer. With 16 years at Vitech, she's one of our leading core experts. Welcome, Donna.
Thank you, Bethany.
And we do have a second extra special guest today. David Long, our president and founder, has also called in to join us and answer some questions. So welcome, David. We're glad to have you. All right, it is time for our first question. And we're going to start with some easy stuff, and that's about the upgrade path. Ken and Kevin are both asking, if I'm current on maintenance, can I get Core 9 at no cost?
Jim, do you want to handle that one?
Yes, of course, and you can get it at no cost. It's all part of your maintenance. Every year we'll upgrade you. Bethany, that's available at the end of the. It'll be posted today at the end of the day, right? Press release is going out tomorrow, so everybody
right.
here has seen things before it's put out to the press, but as of tomorrow, they can begin to upgrade, right?
Yes, we'll make it available on our website some point later today.
Great. And
So
the next question.
our next question is from Dan, and he's asking, Donna, you may want to take this one. Can I go from Core 6 to Core 9? Can I make that jump?
You can. It will take a couple steps to do, and you should work closely with our support, with customer care, in order to make it smooth. But you can definitely move up.
Okay, Donna, what about data transfer? Is that going to be easy?
Data transfer should be pretty easy. Like I said, to work with customer care, there is 1 or 2 steps that you'll have to do to move from Core 9 straight up. If you're moving from Core 7 up to Core 9, that is much quicker. You can import your data directly into the Core 9 application and use all the migration steps through there. There will be 1 extra step to move from Core 6 up.
Okay, great, thanks. And the last one about upgrading, does Core 9 need any different system hardware than the previous versions?
No, it does not.
Fantastic. All right, let's move on to talking about the state transition. We have 2 questions in this area, and the first one's from Jerry. And Jerry wants to know, can state transition arcs be associated with functions that trigger the transition from one state to another?
Well, let me take a cut at that one. We actually have functions as activities. I showed you the do activities, Kevin, underneath there. We have the definition of an event associated with the trigger, and then activities that occur during the transition are defined by functions. And we did that very specifically because we wanted to give people that bridge between the two. Donna, I don't think that a function itself is a trigger. I believe that we just use events as triggers. Is that correct?
That is correct. An event will cause a trigger.
Okay.
Yeah, let me just say functions are deeply embedded in this, but the actual triggering mechanism is an event.
Okay, and a follow-up on that from Thierry is the state transition diagram executable?
It's not executable yet. We wanted to take a deliberate approach to that, and we wanted to make sure that we built it right. We were innovative in integrating the state model to the more traditional types of simulations and functional flows and so forth that we have. So So no, not yet, not in this current version.
Okay, let's move on to talking about risk. And we have just one question in the area of risk, and it's from Jerry. And he wants to know, can you calculate the risk importance based on consequence and likelihood?
The risk rating is actually an option. There is a report that's called set risk rating, and that is on the consequence and likelihood directly. And you can actually define what that would be.
Okay. Donna, I'm going to insert one of my own questions here, which I saw that there were a couple of reports related to risk. Can you tell me what they are and what they do?
As Warren showed earlier, there are two main reports. One is set risk rating, and that you can run anytime you want to, and that automatically updates the database depending on the likelihood and consequence. The other is a report for outputting, and you can, as Warren showed, there are 3 sections to that report, and you can run those independently. It's the risk cube and the risk table, and then just the detailed risk reports. So you can run all 3 at the same time, or one individually.
Okay, great. All right, that's it for risk. Let's move on to talking about the DOORS connector. And Bob wants to know, do you have to use DOORS for requirements management?
Let me take that one. No, you do not. In fact, I've been using various tools for many years, and I really like the way Core handles requirements. It's a different paradigm than DOORS. But I find it a little bit more flexible. It's easier to get information output into different documents. If you have common information that you want to put into, say, a system spec and an interface spec or a software spec, for instance, it's kind of, in my opinion, a little bit easier to do that in Core. Having said that, DOORS is a good tool as well, and it's very focused on requirements. That's what it does, and lots of people use it. So by no means do you have to use DOORS, but if you have DOORS and you want to integrate it, we've made it so that you can keep them all in sync.
Okay, well that leads to my follow-up question from Paul. And basically, how do you keep them in sync? If you have people that are working on requirements and DOORS and you need to keep it current and core, what's the glide path that makes that happen?
Do you want me to answer this, Don, or do you want to take this one?
Well, there are mechanisms in both that uniquely identify the elements in each separate section, and we have the ability to output, actually both DOORS and us have the ability to export and update as we go along. In Core, we have a attribute on each requirement that is a DOORS last modified, so you can make sure that you are using the latest, or if you need to make another transfer of data.
Right. So the incremental, each direction, both from DOORS to Core and from Core to DOORS, has an incremental update capability that Donna mentioned, so that as people make changes in both repositories, you can sync those changes up, and then you can always do a spot check using that last modified by that Donna mentioned. So what we've done is we've provided a comprehensive set of capabilities that really make it very difficult for that information to get out of sync if you're staying up on it.
Okay, so we have a follow-up on that from Well, and I guess he's asking, will the requirements allocation to core elements be preserved when you're pushing data back and forth between core and DOORS?
Should I do that one, Donna, or do you want to do that one?
That's up to you, Warren. You can answer that one.
Okay. Yes, it will. The short answer is absolutely. We've spent a lot of time to ensure that the primary allocation relationships in Core are preserved. Because of the time that we had, we can only show one of those 3 scenarios. But looking from Core to DOORS, the refines relationship, which is requirements decomposition, the specifies relationship, which is allocation to component, and the basis of relationships, which is allocation to function, plus the allocated to, which is a function to component structure. All of that is preserved when you export data from Core to DOORS. So if you have, say, a system level spec in doors and you want to allocate subsystem requirements that came from core to doors, but you want to allocate those to doors subsystem specs, you can easily filter and sort that data and generate those from the information that we're providing into doors. It's actually pretty cool. It's actually pretty cool.
Well, there's clearly a lot of interest in the doors connector. I think that tells me I might have to do my next screencast on that topic.
Yeah.
Okay, let's move on and let's talk about the lock when set feature. We have just one question on that from Keith, and he's asking, once you've locked it, if I'm just in a bind and I really need to make a change, what do I do?
I'll take that one. Yes, we have given you the ability through scripting to unlock elements. If you look when you get Core 9 at the PUID script, there is a clear PUIDs, and that will unlock it for you and clear it. So you will have that capability.
So that would be something that probably they would reserve just to the administrators, I'm assuming?
You would have to be a project administrator to do that, yes.
Okay, great. Let's move on and talk about server export. I have to say this is one I'm super excited about. The improvement of taking an export from 40 hours to 24 minutes is just incredible. So, you know, big kudos to our developer who did that work. Now, Tony asked, though, he wanted to know, is this the same thing as an XML export? When you say server export, do you mean the same thing?
Yes, the server is going to be exporting an XML. It's just going to take a lot less time.
Okay, and how does this work? Is it, what's it doing with the file and how's it getting there? Can you tell me a little detail on that?
Well, it will try to take it back down to the user who requested the export, but if that user has gone offline or for some reason there's an issue, it'll place it on the server and allow you to download it later.
Okay, so what you're saying is it creates the XML all on the server side, and then once
Yes.
the export's complete, then it transfers to the client if the client's still on?
Yes.
Awesome. Okay, one last question. This one's on parameters, and this is from Thierry, and he's asking, concerning the parameters inside a requirement, are they available from another requirement or just from the element that they're in?
Donna, do you want to handle this one?
They are contained to each element. There is scripting that you can do that you can access that parameter, but no, they're not tied directly between, or they're not shared between elements.
Okay, this wraps up Q&A for today.
Can I add one thing? I think that
Sure.
that parameter though can be updated other ways other than just through the GUI user interface that I showed, right? Is that correct?
I'm not sure what you're talking about.
I mean, we can. I'm sorry. So if we had a spreadsheet of parameters, we can use scripting and so forth to update those so that the text of the requirement doesn't have to be touched at all. That would just be handled by the Core 9 capabilities that I showed. That was the only point I was trying to make.
Okay.
Okay. All right. This wraps up Q&A for today. Thank you, Jim, Warren, and Donna. If there's any questions or comments that you didn't send in today, I invite you to post those on the forum of our community site. You'll find that at community.vitechcorp.com. Now it's time to give away a few books. We have randomly selected 5 attendees who will receive a copy of our primer for model-based systems engineering. We're going to send you a hard copy, so after the event, Eva Dace will reach out to you to confirm your mailing address. Those winners are Denny Matthew, Jeffrey Shoebrook, Kyle Hodges, Marcus Bever, and Nicholas Conte. Congratulations, and we'll confirm that mailing address either today or tomorrow. Everyone, I hope you'll join us for the rest of our webinar series, which does continue throughout June. We have, I think, 4 more webinars this week. So I hope you'll be able to join us. For more details and registration, visit our website, vitechcorp.com. In closing, I'd like to thank our presenters today. I'd like to thank all of our attendees for joining us and sticking with us through our technical problems. As we bring this webinar to a close, a survey will open on your screen, either in a new tab or a new window. Please take a moment to provide us feedback on the presentation today, and be sure to let us know any topics you'd like to see covered in a future webinar. Thank you for joining us, and everyone have a wonderful day.